Okay, we're going to look at the skill of linear interpolation for stats. So what does linear interpolation do? Well, it gives you a very good estimation of things like the median and quartiles and so on. So the way we're going to do it with grouped data is like the following. So n is going to refer to our total. Median is going to be n over 2. So in this case, that is looking in the 20th position. Now, how are we going to do this? If we don't already have cumulative frequency, we're going to work it out. So in this situation, from 0 to 10 minutes is 5, up until 20, 8 more, so it's 13 people in total. So where's the 20th student? Well, if you look here, you can see that somewhere in this group is when it happens. But we want to do slightly better than that. So what we're going to do is we're going to say, well, we're going to start at the 20-minute mark because that's kind of our jumping off point, okay, from here. And we're going to go into this category, but we're going to go into this category in a proportional way. From 13 to 20 is going to be 7 more. So we're going to go 7 in, okay, to go from 13 people to our 20th person. We're going to go 7 in, but we're going to take into account how many people are in that group. So we're going to do it in a proportional way. So we're going to go 7/12 of the way in. Now, why are we doing it like this? Well, if you imagine going from 13 to 25 people, and you imagine it spread out, the 20th person, well, they're not going to be exactly in the middle in our scenario. They are slightly further over here. Okay? At the same time, we've got the width of the group, which is 20 minutes to 30 minutes. So we're going to think of a proportionate way to find out, rather than just sort of being not very accurate, about exactly where it is along this continuum of 20 minutes to 30 minutes. So if we know how wide the group is, and the group we said was 12, 7/12 takes us from that 13 to the 20th position. Okay? And then we're going to do a proportionate thing of the distance along here. We're going to assume that everybody is equally spread in a linear way. So our jumping off point, our starting point is 20 minutes. 7 more because this is, to get to 20 people or the 20th position. Okay, 12 because this is the frequency of the group. Anything else then? Well, yes. So 20, I'm going to write minutes as well, just because it's just a coincidence that they're both 20 here. So 20 minutes plus 7/12 of what? Well, it's actually 7/12 of however wide the group is, which is 10 minutes. Okay, so what this is saying is, where do you start? How much proportionately of well, this is the class width, do you go? So our calculation here should be 20 plus 7/12 of 10. And that's how we can do our linear interpolation. So 20 plus 7/12 of 10 should give us 25.83. So this is a better way than us just saying, it's somewhere between 20 and 30. We can do much, much better. And this is how we would do it. You've got a more generalized sort of version there on the screen. But I would encourage you just to get a feel for it and to sort of feel your way through that proportionately, this is our best guess. So let's do another one. 50. So what are we going to do here? We're going to do the upper quartile. So we can do the same with other quartiles as well. So we are going to do the 3/4 point of this. Okay, it does not matter that this is going to give us a decimal at all. So we're looking in the 37.5th position because we're using group data. So roughly, where is that? Not yet. not yet, not yet, too far. So it must be happening somewhere in this group. So we're going to start at the 15 point, and we're going to add on a fraction of however wide the group is. So let's go from here, 33. How far to get from 33 to the 37.5th position? Well, if I subtract, that's 4.5. So I'm going to go 4.5 in this way and 4.5 in this way. What's it out of? Well, you need to take into account how wide the group is that you're going into, which is 10, and how wide actually, what's the class width basically? Well, that's 5. So that would be the calculation on this one. So this is the starting point. This is proportionately the proportionate amount of the size. Let's in fact change the language. Proportionate size of the frequency of the group times by the class width. Okay, and if we do that one there, we should end up with an answer somewhere between 15 and 20. It looks like it's not a million miles off halfway, so maybe 17 point something. Okay, and there we go. We get 17.25 minutes. So let's have a go one more time. 80. How far? The 30th percentile. So sometimes they talk about percentiles. It means 30% up from the bottom. So that's 0.3. That's going to be the 24th sort of position. 7, not there yet. 19, not there yet. 37, gone too far. So it's somewhere in here. Starting at the beginning is 150. How much to add on to get from 19 to 24? That's 5. Out of how wide is the category? It's 18 wide. Sorry, the frequency is 18 even. And the size of the class is 5. So this is the calculation that I want to be doing. It should give me an answer somewhere between 150 and 155 because I'm working out proportionately where in there I am. And it should give you 151.4 centimeters. So there you go, linear interpolation. I would encourage you, far more so than to look at the formula in the book, to kind of get an understanding for why we are treating it this way. Something that you might remember when you've done something like histograms is that this idea is not completely alien. We often have, say, a bar like this, and we divide it maybe into thirds or half or something like that. This is really sort of a type of linear interpolation that we're doing, because we are assuming that even though things are grouped, that they are equally spread out. And that's what we're taking into account when we do this.